So I think what I'm going to do is I'm going to kind of do some review of the last couple things that I didn't write down. And then yeah, then we should be good. And then I will do the exercises, and then we will basically try and build all this from scratch. Mouse input. So as a little extra, the camera system will implement a zooming interface. In the previous chapter, we said that FOV largely defines how much we can see of the scene. When the scene field of view becomes smaller, the scene's projected space gets smaller. Okay, to zoom in, when scrolling, the Y offset value tells us how much we've scrolled vertically. Okay, so the biggest thing here is changing the class to where, let's do these exercises. So see if you can transform the camera class in such a way Alright. Transform the camera class in such a way that it becomes a true FPS camera. Where you cannot fly. You can only look around while staying on the X and Z plane. And then our second exercise is try to create your own lookat function. Where you manually create a view matrix as discussed. At the start of the chapter. Replace glom's lookup function with your own. And see if it still acts the same. Alright, so I think a big thing here is if we want to start with the camera class, let's see what our current camera implementation is. So right now we can kind of look around freely, but we want to be able to just only move on the X and Z plane, not left and right essentially. Well, wait. No, we need to be like clamped, essentially clamped to the ground, I believe. Let's see. So when you make the Y position stuck on the ground. Direction, position.y. Should be working. Let me look. I'm definitely a little stuck on like mouse callback. Let me try reopening this. There we go. I don't know why it was being so weird. So now we're stuck on the ground level. And we should be able to go to our speed, which I don't know where our float camera. There we go. Now we're clamped, so that worked pretty well. It makes sense. We just want to basically set the Y as we're moving. We want to set the Y to. Oh, hold on, guys. Sorry, I got a comment in the Twitch chat. Hey, Andy, how's it going? Thank you for joining the stream. Sorry, I don't really view Twitch as much, so sorry if I missed your comment. Let's see. Okay, so that makes sense where that came from. Now our next thing is create your own lookat function, where you manually create a view matrix as discussed at the start of this chapter. Okay, so our lookat is going to be a map 4, so and then it's going to take 3 float values, so we'll say float. Well, we need 3. Let's see. It's actually going to take 3 vec3s. So and that first vec3 is going to be rotation, translation. Okay, so right vector, up vector, and direction vector, and then nah, and I felt like a pro for programming in Scratch. Hey, everybody's got different tastes in what they do. I would say you don't have to be a pro. I mean, C++ is different in many ways. I'm sure that, like, I haven't even used Scratch hardly, so I'm sure it's different in its own ways, I'm sure. So it's going to take our right vector first, I believe. So let's see. So lookat is going to create, manually create a view matrix as discussed. So not for view matrix. Replace GL. Okay, so. Calculate lookat matrix. Position, target, and world up. That was close. World up. And we actually don't need to pass the reference since, yeah. Number 1 position is known. We have our direction, I believe. Calculate camera direction. Three, we're gonna calculate camera. I'm guessing that's gonna be position. Let's see. We need the right and the up. That's right. Camera right. Vec3 z-axis normalized position minus target. Our direction, okay, yeah, so that's gonna be that. So with our right, I believe we're gonna be X. Might be wrong, but it's probably x-axis, yeah. And then this is going to be our position, probably, and then our world up. Oh, we need to cross them. I don't know how I'm supposed to know this stuff from scratch, I swear. Cross. And then we pass our target and world up. Oh wait, not target. Best, oh gosh, I need to ban this. Okay, so we have an x-axis, and then we normalize and cross. World up. And our z-axis. Alright, and then camera up is going to be Vec3, and then y-axis, and then that's going to be equal to cross z-axis and x-axis. Okay. Create translation and sorry, one sec, guys. Translation and rotation matrix. Which we do GLM map for translation, and then we set this to our identity matrix. Yo, what's up, Rose Polo? Good to see you. I'm just doing some of the finishing up the last exercise for the camera chapter. No, you're good. No, you're good. It's asking me to create my own lookout function, but I'm like, honestly, I got stuck because I knew the steps to what the lookout was, but I didn't know. It gets tricky when you have like all the normalization, so I'm kind of just going over it by hand and trying to understand it all first. In GLM, we access elements as a mat, column, and row due to major column, major layout. Translation 3-0, fourth column, first row. Yeah, I'm honestly just gonna copy this because this is like the one thing that I'm not too sure at the moment, and yeah, I don't want to like waste too much time on this at the moment. So I'm gonna say that I didn't complete this one, and I'm gonna have to come back to it after I understand. Like, I want to go over and do the rebuild from scratch. So didn't complete. So I can mark that as something I can come back and finish later. Because I feel like some of this stuff is like, I don't know, this is a chapter I wasn't super, I didn't really get this chapter too well, honestly. So I'm gonna have to come back and do that for sure. At least just the normalizing and crossing and the math behind it. Okay. Alright, I'm just gonna leave that for now. It's kind of a hard exercise for sure. Okay. So I'm just gonna move on because I don't want to get too stuck. Like, I'm gonna come back and review it anyways. So, review. You've reached the end of the getting started chapters. By now you should be able to create a window, create and compile shaders, send vertex data to your shaders via buffer objects or uniforms, draw objects, use textures, understand vectors and matrices, and combine all the knowledge to create a full 3D scene with a camera to play around with. There's a lot that we learned in the last few chapters. Try to play around with what you learned, experiment, or come up with a bit of your own ideas to solutions to solve some of the problems. As soon as you feel like you got the hang of all the materials we've discussed, it's time to move on to the next lighting chapters. Yeah, I think what I'm gonna do is I kind of want to go through and just make everything from scratch again. So I've already set that up, which is great. I want to make a kind of program that simulates a circle in this. I want to do like a solar system kind of thing. Which will be fun. I was thinking of messing around with graphics programming, by the way. What do you think, Lal? You motivated me. Do it, dude. It's actually really fun. I think it's something that you don't like expect to take, like, you don't need to take it seriously in the sense of like, if you do it for fun, you'll still learn and like it'll be valuable no matter what. Like, even like this last chapter, I'm like, there's a lot of math that I'm like, I don't want to really go through and have to do by hand, but I'm willing to if it's fun and I enjoy it. So like the camera stuff I just did, I'm like, if I need to try and write it from scratch, I'll do it as I'm redoing this implementation. But yeah, I need to do CMake now. CMake. I just need to figure out how to get a basic Oh, see, I don't want to learn all of CMake right now, so I'm just gonna have it come up with the. I'm gonna definitely learn CMake for sure, but I think that it's not gonna be for this stream. The only thing is I stink at maths. I generally, but yeah, I think I'll give it a go. Dude, I suck with math too. I mean, like, that's why I'm like, if I learn it slowly, I'll understand it eventually. Alright. I'm gonna have to come back to CMake. So I think the first thing we'll do is we'll move our library. So let's take our files, which I was gonna also say we probably should add let's add an assets folder or like a data folder. And then in here we can call it textures. And we'll do something different this time because I want to do like a sun. So maybe we can look at, maybe I can draw my own texture. That'd be fun. Include, we're gonna need glad. Actually wait, no, because vendor will be glad. This will just be our include. So let's see. We can put this in source. That can go in there. glfw can just go there. glm. Oh yeah, we do need KHR for our camera. Shaders, we will do that and include. And then we also do camera. No, I don't want a folder named shader.h. And then, oh yeah, we need stub image. For our image loading. Gotcha. Okay. So I think it'd be fun to kind of start by like getting the basics memorized, at least figured out for the most part. So I mean, we got oh yeah, it's not make, it's CMake. vendor GLFW folder is missing. Gotta love AI. I'm just gonna use make, honestly, for now. CMake seems like a lot. I don't need to overcomplicate this for me right now. Oh yeah, I need the library. What is the workspace? That's not what I wanted. I don't like make files. And that's not because it's just because I haven't learned them yet. So I don't understand. That's not what I want to do. to go. Okay. So we got that. Now let's go to the main. That's the hardest part for me, honestly, is just getting everything set up correctly. I know that sounds so dumb. I just want to start kind of small, so we'll do quad. Oh yeah, we need OpenGL math as well, so for libraries. Oh, one sec guys, I'm getting a call. I'll call, or I will be right back, sorry. Sorry guys, I'm back. I was wishing my mom a happy birthday, so I had to call her really quick because I've been waiting to call her all day. Alright, so the biggest thing is first starting with getting our library set up, which I don't want to copy too much. So I think what I'll do is I'll just get these libraries included, and then I will try and do what I can from scratch. Which we got GLM. Oh yeah, this is our math library, so. So this is GLM, OpenGL math. For window rendering. Okay, and then we have GLM, and then we have our GTC. Matrix transformation. And then, oh yeah, image processing. Oh yeah, and then we also need our shaders, which I'm guessing these will just be our include, but let me look. No, these would probably be in our own folder, shaders. And then this will be our vertex.glsl and our fragment.glsl. And then this will be camera will be camera class, camera, I guess just camera, which, yeah, that can be and then IO handling. I guess we could just say debugging console output. Okay. Which I'm wondering if we should have globals just defined at the top of our main, or if we should have like a windowing class. Because I'm not in too much of a rush to go into the next to jump into the next chapter, because I want to get kind of something simple built by myself. Let's see if we can get dev projects and then vendor. Hey, I'm back. Unfortunately, I'm late. Hey, no worries, man. I did kind of start later today. Also, hey Delta, how's it going? I'm really bad at responding today. Yeah, but it's all good. I'm just getting up a new project set up, so all good. Which now we should have our vendor, and yeah, we have our I'm GUI set up, which is great. And then now we can go back into our includes. Which I think, yeah, what I'll do is I'm GUI UI. So excited to see the final result for the Minecraft blocks floating thing. Yeah, so I actually already, I'll show you really quick. I finished that. That was like just the tutorial. And we got that finished to where we can look around, and then we made it so it's fixed on the X plane. So we can basically walk around essentially, as you can see here. And now I'm actually going to write a new project where I can actually, it's something more interactive, I guess, is the way I would say it. So yeah. Alright, we'll just stick with this since we're not using ImGUI yet. Hey, do you try to remember me? XH. I'm not sure if I remember you actually. I have a hard time remembering guys. Yeah, it's also been a while since I've streamed, so I'm so sorry guys. I'm kind of like also so tired. Do you have an idea for your project or what you're gonna do for the project? I mean, yeah. So right now my goal is to take what I just learned from that tutorial and create my own implementation of a project. So, oh, Elytra, that's right. That's right. I was wondering, yeah, I remember who you are now. It looks like you changed your username. But yeah, I want to make my own, I want to take the, basically the whole tutorial of what I just did, but make my own like environment. So I want to make like a solar system of some kind. So maybe like draw a circle in the center of the screen that we can orbit around or rotate around so that we act as a planet. Because we kind of did that with the blocks that we had earlier. So I think it would be kind of cool to do something like that. And then we can have our global variables, which I'm wondering if we should let's see, for our global variables, might be better to just include or do a class instead. But I'm thinking. Oh, also I just realized the camera's like right in the way, so sorry about that. Hopefully this is better for you guys to see. That seems fun. You could also add exploring planets instead of just observing them, like really going onto them by clicking on them if you want to expand it more once you're done. That sounds like a lot, but it also sounds really cool. I don't know if I'm that skilled yet, especially with OpenGL, but I'm sure if I added a way to make it clickable, I could also just render a new environment. That'd probably take a lot more work, but I'm going to start simple so that I stick with it. That's why I'm going to build, just render something pretty simple. So we're going to have our screen. Wait, actually, I'm just going to do this. I'll just do like that, and then globals. And then we can just add this right before here. And then right here we can say include. I don't even need that. And then our global, so we could have our screen dimensions, and then we could say float and then we can set this to 800. Do I know Tokyo Spliff? Yeah, he joined my stream a couple weeks ago, like last week, or not last week, but like a week and a half ago, he joined my stream and helped me out. He was really cool. That seems fun. Fun fact, you finished the Minecraft project around 30 minutes ago, I'm pretty sure. Yeah, you're right, it was a while ago. I've kind of just been messing around right now. I'm not like doing anything in particular. I'm kind of trying to just get my next project set up to where I can... I'm just trying to remember the data types, if that's correct. Because the screen height... Oh, it's an unsigned int. Never mind, it's not a float. That makes sense. Why am I doing a float? Unsigned int. And then we also need, what else do we need? We do need a shader class, which we have here. So if I'm remembering correctly, we need to have a oh yeah, we need to have initialize our GLFW hint. So initialize GLFW and window hints. Yeah, he's cool, really cool and good at graphics programming. Yeah, I think he's a really good graphics programmer. Like, I could definitely take a lot from what he does. This stuff takes a long time to get good at, and I'm like the tip of the iceberg when it comes to knowing this stuff. It's gonna take me a while for sure. This is how I style my programs. I just like to make sure every function has a comment of some sort, like a header. Yeah. Oh yeah, we do need our... That would actually be good. We need an include class to do... We could do user input. And this can just basically process our input, so... Brag once. Let's see. Also, to write text in Python without it affecting the script, do you comment, then a space, and then what you want to write? Then the most important part is what the actual scripts on the next lines. I'm not sure I understand that question. I'm guessing you're saying, like, with a comment, do you do the hash and then... So, like, you do the comment of what it's going to do or what it's going to say, and then you do the actual function? I'm not sure I understand that. I'll just say this class is called user... I'll just call it user input. Alright. And then for our process input, we basically just need your timer's paused. Oh, thank you. Oh, I should be taking a break. Yeah, I'll take a quick break. Let me... Yeah, I'm trying to think here. Let me look. Oh yeah, we pass a window, so... So GLFW... We can also have this handle our mouse input as well. So this can be our keyboard input, and then this can be our mouse input, which mouse callback GLFW window X position. There we go. Are you doing a longer stream today? The stream is about 1 hour and 10 minutes long now. Yeah, I'm just kind of going as long as I feel like it. I'm kind of just hanging out. I'm kind of in a good zone of work. And then our next one would be scroll. So scroll call back. I don't know what the X offset, X, Y set. Y, okay. X offset, Y offset. Our look at, I think, would go into a different class, which we could have. That could be going in our camera class, I think. Yeah, I think that would be a good. Oh, this is a double. Yeah. I'll be right back. I'm gonna take a quick break. I'm just gonna go get some water. I'll be right back, guys. Alright. I am back. Sorry it took me so long, guys. I'll probably stream for another 15-20 minutes maybe. Alright. Our utility class is going to be the one that we use to use Dear I'm GUI with. I'll do one more. You know, I'll do a 30-minute. I'll do one more 30-minute bout. Okay, let's see. So we have those handled. This can just go in. This can go at just at the bottom. Okay, so we have our screen dimensions. We need our delta time as well, so. Which I kind of just want to handle that inside of a class as well. So let's see. Delta time would be, I'm trying to think, what would a good name for that delta time class be? What would a good class name be for handling delta time and frame variable framing methods variables, so I don't have rules. Okay, so we can have our clock. Yeah, clock class would probably be good, so. Or maybe just timer. Yeah, let's do clock. Which we don't even need to include anything. I think time would make sense because of delta time. Yeah, but there's already a C++ time class, which is in the standard library that we wouldn't want to interfere with. So I think clock makes sense because that's a similar thing, similar idea. I have an idea for a project. You could add Pluto, except it's an Easter egg, and it only appears if you type Pluto is a planet. Of course you don't have to do it, I'm just saying. That'd be cool. I mean, I have a long ways to go, I think, before I can do anything like that, but maybe I'll add that in the future, if I'm ambitious enough. Let's see. What does window hint mean? I'm curious. Of course, you don't need to tell me everything, it's just simple. Window hint is essentially telling GLFW, which is our windowing tool for how we get. So basically, when we have a window, for example, we have this window right here. It says Learn OpenGL. It's something that we can view graphics inside of. A window hint basically says, hey, we need to make sure that GLFW is this version and using OpenGL in this profile. So what are we using to render into our windows? So basically it gives it's like a settings essentially. It's like a profile, like a config essentially, and to my knowledge. Oh, so it's like make sure to up to date using OpenGL inside of the window. Kind of, yeah. I mean, it's basically saying, hey, we want to use this version of OpenGL, and any other tooling that we have. And basically, if you don't initialize window hints, OpenGL or GLFW won't know what it's looking for. So yeah. So now we want to create a window next we can just call this solar simulator, and then these will be null. And then handle errors if window doesn't open properly. Which I forgot to put this here. I probably should do this. Always add error handling in your code. It'll save you so much. Like, add debugging, because it'll save you so much time in case you don't know where it's coming from. Okay, so now we want to say window failed to initialize or failed to create yield. There we go. Line 54 is wrong though. There shouldn't be a exclamation point. Let me see. No, that's correct. That's correct. We have the exclamation point because that's basically the null terminator, I believe. So it's basically saying if it's the not binary operator. I don't know if that's the right name, but it's basically saying, hey, if our window does not equal null, then we're gonna I guess it's basically saying if our window doesn't pull up, then it failed to create. So yeah, it's if the window is not null, then throw an error. Basically, yeah, exactly. No, actually, it's. Let me try and. If it's not the window, if the not window equals null. Let me find a better way to explain this. I'll. Because I'm having a hard time. How would you describe this? Flips the Boolean value of window, then compares the result to null. It's not a bug. Check that failed the window. More identically in C++. Oh, either one correctly catches a null pointer. It should be right, because I just went off of what it... I'll just say if it's like that. Basically, it's saying if it fails to catch the window. It's because in your other VS Code window, if it's in null. Yeah, I'm kind of going off of it a little by little, but you bring up a good point. Actually, let me go to learn OpenGL and look at what they had. Because that will give us a lot more context of what is correct. Yeah, so let's see. Oh, if window equals null. That's basically the same thing. So if we just said yeah. Gotta go. It was fun watching the stream. Hey, thanks for being here. Have a good one, and yeah, I appreciate you being here. Now it makes sense. Yeah. You're totally right to question that. Because I had the same... It was basically doing the same thing, I just had I had an extra step that I didn't need. Because it's basically contradicting itself. Yeah, anyways. So now we have our window. And now we need to make our contexts. So... I'll do this in a little. Oh yeah, we need to do initialize glide. I'll probably be done here in a few minutes. Alright, now we can go to our now we should be able to just try making a window, so let's see. Alright, look at that. So now we got our solar simulator, which our solar simulator is just gonna have like a black background. So yeah, we'll just give it a basic black background to start. And you know what? I think I actually need to do I'll do 1200 by 600. Actually, no. Sorry, I'll do 800 by 400. By 600, that's what I meant. Because we want it to be pretty even. There we go. So now we got our window set up like the basic window. And I'm wondering if we can have a class. I think it would be smart to handle a lot of this stuff inside of other classes. So I'm going to say we're going to handle our oh, mesh, okay. That's good. So our mesh will handle mesh underscore h. Perfect. And then we also could have a texture class probably. What are if and def and define for? They're preprocessor macros that basically tell our, whenever we're compiling and linking our classes, it needs to say, okay, what is the header file I'm looking for? It's basically like a C++ thing where it makes it unique. So like if someone had a different object or instance of mesh or something defined somewhere in our wide array of files, it catches it. So it's basically really, it's a really good way to make sure that our classes are set up right. In fact, what does if and def? This is a better way to explain it. Preprocessor directive that stands for if not defined, checking whether a specific macro has not been previously defined before processing the subsequent code block. It is primarily used to create header guards that prevent a header file from being included multiple times, which would otherwise cause redefinition errors for classes. So it basically makes it so we don't redefine the same class over and over, and protects our class, our header. So our mesh. And we also want a texture class. You could also use Pragma once, but I think this is a better, doing it by like this is probably better. It's more standard. I might be wrong though. This is everything we need to know about vertex, buffer objects, vertex, array objects, element, buffer objects, and vertices, matrices, and other data. Oh, hey, how's it going? Burnseye and Mike Harley. Sorry, I just saw your guys' comments. I haven't been checking Twitch much. I'm building well, I just learned a little bit of OpenGL, so I'm gonna try and build a solar system simulator of some kind. Sorry, one second. I need to bring my wife her laptop. Too busy. Seems like the game market is going to crash. Yeah, it might. I don't know. I'm just doing this for fun, so I'm not in it to lose anything, which is great. I will be right back, so give me 2 seconds. Okay, guys. I think I might... let's see. What's developing, by the way? That's mad. Did you see the Earth pick Artemis 2 pick took yesterday? Yeah, it's awesome. I'm just learning OpenGL, like I said. Anyways, I'm probably gonna have to end stream here. I have a Discord if you guys want to join and tune into the next stream. I appreciate you guys hopping in here. I'm sorry I have to go like right as you join. I'll put that in the Twitch chat, and then if you guys are in YouTube chat, feel free to look there as well. I'll probably be back on tomorrow because I'm really liking what I'm doing. Just might take me a minute to get all this set up to where I can actually get stuff drawn. But yeah. Thank you guys for being here, and feel free to sub and like the video or the stream. Obviously, if you're new to the channel, subscribe if you want to be here for more streams. I love learning, and it's been a really good process for me to just talk on camera and get my thoughts out, and yeah. I will see you guys in the next one. For now, I'll let you guys know in the Discord when I plan on streaming next. So yeah, I'll talk to you guys later. Have a wonderful night or day wherever you are.